Hello, everyone. Hope am I audible with you?
Yeah, you are.
Yeah. So today we are happy to have the industrial talk on an introduction to virtual reality and 3D computer vision as a part of the machine learning internship, right? As a part of the machine learning internship. And we are happy to have among us Dr. Joseph H.R. Isaac, the data scientist from Ericsson. Dr. Joseph H.R. Isaac is a data scientist who's doing research and developing projects related to natural language processing and image processing in Ericsson. He has completed his interdisciplinary PhD in IIT, specializing in the field of machine learning and virtual reality. He has authored and co-authored 10 publications till date. During his time at IITM, he has conducted several deep learning workshops, including some in Anna University, and also had presented an online webinar in UC Dallas. His main interest includes image processing, deep learning, virtual reality, biomedical engineering, and natural language processing. And for today evening, on this industrial talk on topic and introduction to virtual reality and 3D computer vision as a part of the machine learning internships by the students of SDNB, almost 120 students are here. And also this entire session is also streamed on the YouTube, and we have faculties and scholars and students, and the direct interaction between Dr. H.R. Joseph and will be within SDNB college students and people watching on the YouTube. You can share your queries on the YouTube live chat. All right, at the end of the talk, your queries will be answered. All right, and for the people attending the talk on the YouTube, listen to the talk carefully. At the end of the talk, feedback link will be given. For all the participants, participation certificates will be given. More than the certificate, try to get the essence of the talk. And in spite of the busy schedule, we are happy to have among us Dr. Joseph H.R. Isaac. Over to you.
Thank you very much for the introduction. So let's begin. So good evening to everyone, and hope you'll be having a good time in this talk. Feel free to ask any questions as I'm presenting, so you'd like to be interactive. And just share my screen. Just let me know when the screen is visible. Okay, are the slides visible? Yes. Yeah, hello, are the slides visible?
Yes,
Great. So hello everyone, welcome to Convolutional Reality 3D Computer Vision.
Excuse me.
And the introduction,
there's a slight disturbance in the audio. There's a slight disturbance in the audio.
This is a disturbance? Okay, I'll try to switch to earphones. Audible now? Yeah. Okay, great. Yeah, sorry for that. And thanks for the introduction. As they said, my name is Joseph, and I'm a data scientist at Ericsson. And I'll be presenting an outline as to what it's going to be on. First, we're going to do an introduction to what is virtual reality, and as well as the implications of virtual reality, along with its challenges. Then we're going to see what is the advent of artificial intelligence in virtual reality, i.e. deep learning and its uses and its applications related to virtual reality. Then we're also going to focus on one of the use cases, that is hacking, because that is what I was specializing on. I was doing my projects in here, as well as some challenges you might face. We're going to give a very rough introduction to hand tracking and not a very deep dive into it. So just like an overview on how it looks and what are the overall challenges you face when you're doing such a project. It'll be a good idea and a good eye-opener when you are getting into machine learning, specifically in fields such as computer vision, which is called machine vision. So let's begin with an introduction to what is virtual reality. The basic definition of virtual reality is that it creates a simulated environment using computer technology. And that simulated environment can be in the form of visual, auditory, and haptic signals, sometimes even smell. There are even technologies such as those which are, I believe, done in China, where they're even seeing smell responses, like if you're going in the field of grass, you'll also have that smell of flowers and things like that. So the major divisions of the fields related to virtual reality is called as XR. That is virtual reality, augmented reality, and mixed reality. And let's see what are those in a little bit of a detail. Virtual reality is basically in the sense you are in a new virtual world with nothing in the real world that is connected to you. You are wearing some equipment that is usually in the form of a headset, and you'll hold some controllers, and then that's it. You are totally placed into a new world, and you'll feel and interact everything in that new world. There's nothing in the real world that is interacting with you at that, except for the controllers and the headset that you wear. Augmented reality, on the other hand, is that digital elements are placed on the real world. So if you've seen this particular example, it's a very popular app which is known as Pokemon Go. And Pokemon Go is like you hold the phone and go around catching Pokemon. You'll see the actual real world. And if you go look at the lake, you'll see something in the lake. And those digital elements are kept on the real world, and you'll interact by using your phone and scrolling it. And you'll be tapping or interacting using your phone. Mixed reality, on the other hand, is a blend between virtual reality and augmented reality, where you are actually interacting with the digital elements using the real world elements. That is, sometimes your hand or even objects. This is a difference in the case in augmented reality. You have to use your phone to interact. You'll tap, you'll swipe, or do anything. But mixed reality, as you can see, I'm using just my bare hands and moving it side to side, but it is actually interacting with the objects, and you can see those digital objects are changing in properties. So the major players in this case is from Oculus Rift, HTC for the HTC Vive, and Sony from the PlayStation VR. So these are major players, but there are also many other startups and other companies which are also there for VR and VR related products. So in terms of applications of VR, they're very good applications, and most in terms of important applications, the first set is the simulators. And simulators, namely medical simulators, because in medical simulators, when you want to learn a medical procedure, like if you're a doctor and you want to train for some surgery or something, you will not be always allowed to do surgery on actual patients. I mean, like if you're a fresh person who's studying MBBS or something like that, then if you're studying and if you want to do something like a heart transplant, you will have to first learn very well. And only then they will allow you to even touch real patients. And one very good alternative is using virtual reality. You wear a virtual headset, you could perform those difficult tasks. And if you're making a mistake, it's a mistake made in the virtual environment. So you could easily restart it and do it again. And you'll also learn much more better than just reading some books and trying to analyze it in that way. So in that sense, medical simulators, not just like heart transplant. I'm telling you could be like all sorts of medical procedures, like needle insertions, and the one that you're seeing in the picture is a tool that they want to insert into the throat to measure something which is in there. You have to insert it exactly the correct amount. Too much, you might injure the throat. So they'll teach you how you're inserting it and so on. So it's very fun, and it's also very useful to learn. Next is driving simulators. So for example, Formula One race cars. If you're learning to drive such a fast car and if you're making any mistakes in it, then it could even harm yourself as well as lots of expense in the cost of the cars. But if you're learning it in a virtual space first and then going to the real environment, it will give you some benefit. In the case where you could see in here, this particular jig, that this rig that they're sitting on, it actually shakes as you move around. So that gives you a form of comfort where you move around, and it'll also give you that feedback as if you're actually driving a Formula One race car, and then they'll go on to the real environment. So in terms of teaching as well as gaming, this is a very good tool like for driving simulators. Next is construction simulators. So the same thing, they want to reduce the expense of trying to teach someone. If they give you a crores worth of crane and then making you to learn from it, they have to use in the buildings and in constructions anyway. So you'll learn in reality first by using the same kind of tools. You'll learn how to move the crane, how to learn about the interface. Then it could work in the actual, they'll match the controls, they'll match all the features as such as the real crane. This way, they'll be well practiced. They'll learn tasks. They'll also practice picking and putting down objects in various scenarios, and they'll get better improvement in here. So they'll learn using simulators in these cases. And then, of course, for gaming, it's fun. You could feel as if you're in like Spider-Man, actually be shooting webs and moving. They actually give these kind of like vibrators and things in the wrist. So if you're like shooting a string, you'll feel as if you're shooting something. And when you're pulling it, moving forward, they'll even give you some feedback in the form of vibrations, or even maybe a motor which is attached in front of you that'll be shooting wind at you, so you feel as if you're trapped. So that's all fun experiment. The other kind of games is shootings. Of course, you could wear a virtual headset, hold a gun, and then you could pretend as if you're shooting. And then in the virtual environment, you actually be going in different areas. So in gaming, there's all sorts of games that can be done with VR. And another important one is designs. So this is an example in which car companies, they actually use virtual reality to design what kind of car will they have. And even after designing, they will automatically test, like if you're having a very fast car, they have to test something like the aerodynamics of it. So if the winds are traveling fast, it should smoothly go around the car. If it is having any sharp elements, it will block the wind, so you will slow down your car. So they will automatically do this in software rather than them creating it in hardware and then testing it in some, let's say, in a mechanical studio. They could actually do it via software, and if they make any mistakes, they could easily adjust it. Then when they have everything perfect in software, they'll then move it on to hardware and make a first prototype, and that prototype will be much more better than what they've created so far. So for designing, it's also really useful. So those are the kinds of applications in VR. As in terms of the challenges in VR, there are things like latency-related challenges. Latency is in the sense you are playing a game, let's say, and if I'm telling you to shoot something and then you have to immediately shoot it, otherwise you miss it. So the latency case is, if I press a button in here, how long will it take for that to happen in VR? Or if I'm doing some driving simulator, if I'm turning the car, it immediately turns in the actual game. Otherwise, if you're turning the car and after 1 second, if it's turning, then that might, you might skid and then you'll lose and you won't feel that much, immersive. So that is latency related challenges. How we're going to improve the VR such that your latency be very low and you'll finish your tasks very fast. And the processing power is also much better. The other one is HCI related challenges. There are lots of studies on HCI related challenges in which if, for example, if I'm moving my hand in the virtual space, I am moving my hand 1 centimeter forward. How much time will it take for it to move in the virtual space, and how much will it move? I move my hand 1 centimeter. In the virtual space, it'll move 5 centimeters. Is that comfortable for me? Or is my hand 1 centimeter that should move like 6, or it should move 3 centimeters? Is that more comfortable for me? What are the most effective types of interactions I could have in the virtual space with my controllers or any kind of tool for that matter? So that is HCI, because any tools is HCI. Human computer interfaces is like your mouse is such a device, keyboard, controllers, even graphics tablets, those kind of devices. Next is health related challenges. You could wear a virtual reality headset, that is the problem. But how long you're wearing it is the thing. If you are wearing a headset for more than, let's say, half an hour or even 40 minutes, you will start to feel the kind of like nausea because the screen is right in front of your eyes. And if you're focusing on something very close to your eyes, that gives a strain on your body. And that'll cause a strain in your mind, and your eyes will start to feel fatigued. And that's when you get nausea, giddy, headache, everything. That's why they recommend you only play it up to 20 minutes, take 15 minutes break, then play for 20 minutes, things like that. Now they're trying to develop devices such that it does not cause fatigue. If there's some fatigue, you should automatically rectify it just with this hardware itself. So they'll spend longer time in VR. The other one is cost-related challenges. Of course, Oculus Rift can go for lakhs, and that's very expensive. So they're trying to make like low-end devices that even mobile devices that anyone can easily wear and play in VR. So let's focus on one of the challenges, such as hand tracking. And this is an example in which even Oculus Quest, it's very good. You just wear it, it's not connected to anything, but your hands are tracked very well in it. So for definition of hand tracking is that given an image of the hand, track it in 3D space both efficiently and accurately. But wait, there's more. It's not just the tracking. We want it to be following the constraints. The constraints is if I track my hand, tracking my hand is I move my hand in the computer, in my camera, or else in my VR. I want that hand to be seen in the game that I'm playing. So it must be a continuous motion. So if I move my hand smoothly, it should move smoothly. And then the hand must not, if I move my hand should not be like shaking about in the virtual space. It should not, that does not look good. And my hand pose must be realistic. So if I keep a hand pose like this, it should be like this. It should not show like one finger here, another finger there, or it'll look awkward. So there are two types of hand tracking. One is 2D tracking, the other one is 3D tracking. 2D is, as you can see, I move my hand, it will just show a box where my hand is. And that kind of box will move around. 3D tracking is if I move my hand, it'll tell me exactly where my finger positions are. So that is 3D tracking. So these kind of hand tracking requires something known as deep learning. So the question right now is, what is deep learning? So it's very simple. Let's just begin from machine learning, and then I'll just shift to deep learning. So machine learning is a kind of science where you learn from data. But deep learning is a subfield of machine learning, which is inspired by something known as artificial neural networks. Deep learning is a part of machine learning, and machine learning is a part of AI. That is the kind of subset I want to tell you. So let's look at neural networks and a small introduction on neural networks so you understand what is deep learning from there. So to begin with the computer neural networks, you need to know what is the actual brain neural network. So if you look into the brain, the human brain, what do you see? What does the brain consist of? Neurons. So the brain is consisting of all neurons connected together. So these neurons are linked to one another, hence they form this network. And what we're trying to do in the computer is the same thing. We have this individual nodes that is connected to other nodes. And whatever you send information to this node, it will send it to all the other nodes. So that is the kind of transmission that happens, the neural network. And if you want to do something, you will send some input. It will go to some nodes. It will process in all the other nodes, these elements, the nodes, and it will then give you a final output. So that is a neural network. So let's see how a neural network works. So this is just one neuron. So this is a single neuron, which is one element of the neural network. And the way it works is you give some inputs, like let's say some random numbers. I'm just given some random numbers in here. Those random numbers will then be multiplied with some weight. They call it weights. And those weights will then be, so this number and weights will then be added and kept into a function known as activation function. And that activation function will then send you a final number. For example, this activation function is something known as sigmoid. Just for starters, let's not worry about what is sigmoid or anything. It's a simple function where you could see in here. This is, I just plotted the function for ease of understanding. If it's any negative number, it'll go to 0. If your input is any positive number, it'll go towards 1. Okay. So for example, I have given some random weights in here. My random weights, if I'm multiplying, so this into this, and then this multiplied by that, and then this multiplied by that, I'm adding it all together. I get a number 21.34. I put that my function here. This 21.34 will be somewhere in the end. So it'll be 1. So technically this f of x will be 1, and 1 will be sent to the output. That's what this one node is doing. So to look into a full neural network, this one node actually n nodes all connected together. So let's see how it works. So now we have something known as train a neural network. How do we train a neural network? I have this set of nodes connected. I told you, right? The nodes are connected from start to finish in a regular manner. And I told you that each node has a set of weights. So in order to start training, so I will make that set of weights some random weights. I'll just keep some random weights across mine, look for the weights section. Now I will have this data set. So this is my data set, some example data. So data set is just a set of input features, which is then mapped to a particular output class. It could be a class, or it could be some other number as well. So regression or classifications. So for in this case, I'm showing classification. So it'll either be 0 or 1. So I have a set of numbers, and my result will be 0 or 1. So in this case, I have given the first set of numbers, 1.4, 2.7, and 1.9. It is doing some calculation, like I said, multiplies and goes through. My final answer is 0.8. But what should my answer be? 0. So hence, that 0 and this 0.8, I will check the difference. My difference is 0.8. Based on this error, I will change all those weights. I told you, right, those weights are there. So I will keep on changing it. And the whole concept is I'll send an answer, check the result, find the error, which is the amount of correction that's needed, change the weights accordingly, repeat the process. And this can be repeated for like 1,000 times or even 1,000 times or so, and then keep on correcting. Eventually, I'll get the exact number I need. Not exact, but very close to the number that I need. So this is in terms of a regular machine learning. So let's see what is deep learning in here. Deep learning is the case where I've told you, right, that I have a set of nodes which are connected. The deep in this part is the set of nodes is actually a very long set of nodes. So a regular neural network would be like 2, 3, even 5 or 6. But deep neural networks would go for hundreds or so. So as in, if I want to tell you the comparison, this particular network you're seeing is just one input, which is the black section, one output, which is the right side black, and the inside section, that green color, is one layer. So this is just one hidden layer. So if I'm telling you deep network, this instead of this one green, you will see like 100 sets of like green lines all across. It'll be that big of a neural network. So that's basically what neural network is. So to show you a difference, if machine learning is a peanut butter jam sandwich, then neural network is a huge hamburger with the triple double layer cheesing. Okay. So learning the weights that this training process I do, when I'm doing it in small networks, pretty easy. But if I'm learning the weights with very, very long networks, very large networks, that is when it's very, very hard. And that's when you have to do different kinds of algorithms. That is where deep learning comes in. So another case is that regular neural networks will find very hard for image-based classifications. So it will not work for very complex data. However, deep networks work very well on this kind of image-based data, specifically something known as CNN, which I'll get to in a minute. But for now, let's just get into deep learning. So we're performing models with the classification task that uses images, text, or even sound data, and that can achieve state-of-the-art accuracy with very good performance. So now that you have an overall understanding on what deep learning is, let's get to VR with that. So now, as I said, for hand tracking uses deep learning because, as I said, using computer vision-based data. So we're going to take input like a video or even depth cameras. So special cameras are there. They will take input and it will be processing. So that kind of camera input, pictures are used. And for pictures to be used, you need very good neural networks for that. And that is where deep learning will come in. And other cases is for training simulators. So there'll be a kind of simulator where automatically, when you're doing something in VR and you're playing some games in VR, the points you're getting, based upon that points, some things will change. So that automatically you'll get harder. So you're playing a game, you're playing it very well, and it's very easy for you. Automatically, they'll change some things in the game, like they'll make your health go down. They'll make the enemies to behave much more fast or much more harder. So in that sense, that kind of training simulation. So the AI character, that is the artificially intelligent character, will perform better automatically using deep learning. Another one is gaming. If you're gaming, you're playing with some computer characters, right? So the computer characters learn using deep learning. So they're learning how to play with you or even play against you. So that is also using deep learning. The other one is VR marketing. So VR marketing is actually a very good case where when you are shopping in virtual reality, or else if you're not just for marketing, it could be anything. So when you're performing those kind of tasks, your view, that is where you're seeing, be recorded. And using that recording, they could actually analyze about what people like. So for example, I'm in a shop. I keep on going to the shampoo section, and then I'm buying lots of shampoo in this particular brand. So they will analyze that, okay, this brand is more popular. Let's adjust it accordingly. Let's keep this in this section. So many people come to that section, and they'll get that section more popular, and they'll see new brands as well. So that kind of market analysis can be done. So here's a cool application using deep learning I wanted to show. The input for this program that you're seeing is just the voice. Using the voice as input, the computer automatically, they give the voice and they give a model, a 3D model. The computer automatically animate that 3D model using that voice. So check this out. I'm not sure if the voice you heard, but I'm just want to show you this output. So you can see the fact that the so you can see the fact that the expressions and everything are actually animated with this graphics, and it's really good. And the input for this animation, they didn't actually do any manual work. They have just given the voice. The audio is given, and it automatically actually created all this animation, which is pretty good as well. So let's move on to hand tracking with all these examples and fun ideas that we shown. As I said, 2D and 3D hand tracking. 2D takes the box, while 3D takes the actual position of the hand. So 2D hand tracking, like I said, it uses the models, which is known as CNN, which is a convolutional neural network. So I give an input, and what the CNN does is it will actually find out what are all the best places a hand can be. And from there, we are going to take the best selection, like I say with the 20% chance hand is here, 50% chance hand is here, 90% chance hand is here. You will then take, okay, what is above 60% or something? Then they will give you exactly, I will look here, these are the two places for hands. So that is like 2D hand tracking. So what is a CNN? So just to give you a brief introduction on what is CNN. CNN is that the neural networks, it's the same kind of neural networks, but they use something known as convolution. So there'll be something known as convolution layer, and there'll be something known as pooling layer. So I'll just show what are those two layers. That will then be passed to a final set of values. Those values will then go to this regular CNN that you have known. So we have talked about the standard CNN and how it works, right, with just the numbers. So this convolution part will finish, then it'll go to neural network. What is convolution? So in this case, we're going to take a set of numbers. So in this, we're having, like, let's say 9 numbers. And that's what you're seeing in here. There are 9 values, which is sliding. That is sliding across the picture. What is your image? It's a set of pixels. The color points. And each color point is like a number. Let's say you have a number from 0 to 255. And then you take this 3 cross 3, which is the 9 values. You will then go on each part of that image and you will multiply each part like this number with that number, multiply all the individual 9 parts, add them together, and then take that as output. That is what convolutional is. So we're having a kernel which is, I think, is 0, 1, 2, 2 to 0, and 0, 1, 2. That's going across this image one by one, and it's multiplying all those values, and you can see that's resultant values here: 12, 12, 17, 10, 17, 19, then 9, 6, and 14. So it's multiplying across those four. And for maths, you can see that the image is of size HWD, which is height, width, and depth. Depth is like you have a image. An image is a red, green, blue image, which is 3. So you'll have 3 values. So if I have, like, let's say 1080p, you have already heard of 1080p. What is 1080p? 1920 pixels wide, 1080p pixels height. So that 1920 into 1080 into 3. That is your image size. And then my filters, I said 3 cross 3. My output will be this particular equation in here. So that from that CNN, I will then calculate those 3 values, those final 3 cross 3 values. And pooling is basically, I will take a group of those values, find the average of it, or else I'll find the maximum of it, and then I will take it. It will make this large image smaller and smaller and smaller until you get the small set of numbers, and that small set of numbers will then go to the CNN. So that's a very light view on CNN. If there are questions, I'll take it in the end on that works. So what is the benefits of CNN? First is the reduced number of parameters. So I told you that weights in the neural network, right? If I want to just bring a very quick thing, if I have you like a 100 cross 100 image, that is 10,000. That 100 cross 100, if I put a neural network, you could imagine that 10,000 weights will be then need for each and every node to learn this full network. But in a CNN, it's the 3 cross 3. That 3 cross 3 will go to the entire 100, 100, and that one layer will be done. So reducing all these weights. So if I reduce how much I have to learn, it will get better for me. That's how machine learning works. I don't want to learn so many numbers. If I learn so many numbers, it gets hard for me. So the next one is something known as interpixel dependency. So I'm looking at my picture as a picture. I'm not just breaking it into numbers and just sending the numbers. If I'm seeing an eye, it should look like an eye, and then I'm taking the fact that it looks like an eye. So that is something like interpixel dependency. And also, you could see that it can make a very complex network. If I make a lot of layers with it, I will learn many things from that picture itself. So looking in a 3D perspective, for hand tracking, first we're taking the picture of the hand. So you can see that I have a photo. From that photo, I'm seeing the picture of the hand. I also have a depth camera. And from that depth camera, you see this is a special camera. So special camera can tell the 3D part of the object. We will then take that hand that you have seen in here and then put it into another CNN, a special CNN, which will then find the position of that hand. So that's how the 3D hand tracking works. And broadly, there are 2 types of 3D hand tracking. One is direct regression. Like, for example, I am telling my hand is in here, like 0.123. It'll tell the position of each part of my hand directly. The other one is model fitting. Model fitting is I will have a 3D, like let's say I have a 3D model of the hand. It will automatically move that 3D model and position it such that it matches my hand. So the one is directly just telling the position of the hand. The other one is taking a hand model and putting it in there and then fitting that hand model correctly. So for model fitting, there's a sample example paper which is as shown. You can see that taking the input, which is that 3D, that 3D camera I was telling about. It passes through several of these kind of convolutional neural networks, and then it finds out the position of the hand. The output, I just want to show the last output, where you could see that it's actually a gray color model. That gray color model is actually inside the software, and it makes it in that same shape, similar shape, and then keeps it there. So that is model fitting. And limitations of such model fitting is that if you move very fast, then the model will be like flying somewhere else. And if you're not having this correct hand size, so I have a small model of a hand, but my hand is very big, it does not know how to fit that model, and then you'll get some mistakes. You should have a correct model size to fit your hand. This is like you're wearing a shoe. So you should have your correct shoe size. If you have a small shoe, then it doesn't fit your hand. So it does not give you the correct output. The other one is direct regression. Like I said, it directly just tells position that points the hand. So an example is in here where a similar one I've shown you. We have a picture of the hand. It will first find where the hand is, the overall picture. From that hand, it will then find that individual joints of your hand, that individual knuckle position, all that little parts of your hand. It will show exactly where it is. So that is direct regression. So we have seen the challenges of hand tracking for the 3D and 2D is that, so 3D hand tracking with just 2D images is not good. That is why I was telling you, right, we're having this special camera like depth camera and 3D cameras. If I just have 2D camera, it's actually an ongoing field. There's a lot of projects in it. If you're interested, you could check it out. Just with my camera phone, if with my phone, I just take a picture of the hand, I want to get the 3D position of the hands. They're very good projects that you could do for that. The other one is it's not suitable for very good accuracy. Like I said, it'll shake a lot. So if I'm thinking in medical procedures, I want to learn like surgery or something, right? I can't use just the 2D camera. It's not very comfortable. It won't be very accurate. But the other problem is that 3D camera is very expensive. So to get a 3D camera and position it and use it, that 3D camera is very expensive. So the other solution is I could use some 2D and some 3D. So I'll have benefit of 2D and 3D hand tracking and have the benefit of 3D hand tracking and more efficient. So to summarize all the things that I've been talking about, VR is into a bright future with the DL, with the deep learning. There's a lot of applications out there which uses virtual reality, and there's a lot of scope for a lot of projects and a lot of different ideas you could implement in virtual reality using deep learning. And we learned the basics of deep learning and neural networks. And overall basics, I wouldn't say that I got justification for the whole neural network on how it works, but just like if you know what is a neural network, you could tell at least 3 lines for it. Then we saw hand tracking and how that hand tracking is used in VR, and we saw 2D and 3D hand tracking and challenges. So with this, I'd like to give my thanks, and if there's any questions, I'll be happy to take it.
In basics so that everybody will be able to understand. And we have a couple of professors and the students in the YouTube. You can post your questions, any queries that you have that I'll be able to ask Joseph, and he'll be able to respond to you back. And students from SDNB, especially this is for you. And these are like 130 students. They are having their machine learning internship online. And this is the first industrial talk, and next Wednesday we'll be having the next industrial talk. Students, if you've got any doubts or any queries regarding ML, machine learning, deep learning, or VR, you can post your questions, so feel free to unmute and ask the question. The time is yours.
Yeah, someone raised their hand.
Is Renosha? Renosha? Have any questions?
May I ask?
Yes, please.
Please. So you were talking about the weights and how there are multiple levels, which you just put the basic example.
I couldn't hear you clearly. Are you audible?
Actually, is it? Yes, that's fine. Can you hear me now?
Yes.
Yes. I hope I'm audible. So I was asking about this. You were talking about the weights and the. I'm not sure where exactly it was. There can be multiple levels, and there can be shows.
I'm unable to hear the audio. Are you able to hear it?
Ramya, can you also post the question on the chat? Yeah, I'm able to hear, but you're able to hear me?
I can hear you, but I cannot hear Ramya.
Okay, Ramya, post the question on chat. All right. And there's another question by a professor. What is the difference between CNN and RNN? Can you give an example for these?
Okay, so CNN is in the case of convolutional neural network, and RNN is recurrent neural network. Are you talking about recurrent neural networks, right?
Yeah.
Okay, so so there are actually two types of recurrent neural networks. There's something called RCNN, which is recurrent convolutional neural networks. But in the case of just a recurrent neural network, it's a neural network which takes the output and then feeds it back into its own input. So in the case of a very good place where I could tell the use of a recurrent neural network is recommendation engines for text. So if you're doing like something like Google search, and when you're saying, I would like to buy a, and when you finish with that itself, it'll automatically say, I want to buy a shoe, I want to buy clothes, I want to go shopping. It's giving that recommendation, right? How does it work? So the fact is that I am typing my letters like I would like to. Those words are all taken to that recurrent neural network. The way that the recurrent neural network works is that it takes the account that my word by word I'm telling one word after the other, right? So the order of those words are learned in succession. That's the fact that the recurrent part, and then it automatically gives you the next set of predictions. CNN on this hand it's something that to do with the images. So it takes an image, you'll either classify it or else you'll either regress something. And recurrent neural networks in the form, I want to have something which is time-based. So my time-based predictions, I want to have something which is of time t+1. That is where recurrent networks work. There's even something called recurrent convolutional neural networks, which takes a video feed. So my video feed is as such. And with that video, it will take something like there's hand tracking with RCNN. So it will take the positions of my hand in all the time. It will predict what is my next position based on time itself. So that is what mostly time variant data is used for, is effective with recurrent neural networks. And CNN is just like, image-based data.
Thank you so much.
Yeah, so
any other questions, girls?
Hello, sir. I was wondering if you could explain a little bit about the weights in neural network, and please give an example, maybe. Okay. So the weights part is
That's
that, like I've shown.
You can explain.
Yeah, we had the question in the chat. Hello. So the question here I've seen in the chat is that if they're wondering if I could explain a little more about the weight in the neural networks and also give an example. So like I've shown in the slide, weights is actually for in my neural network, I will have something known as my input. That is my set of inputs. For example, I have 5 inputs. So I have 5 nodes. I have 3 in my hidden. Let's say I have 3 in my hidden. And then I have, let's say, 1 in my output. So my 5, 3, and 1. So this 5 will be all connected to this 3. And this 3 will be then all connected to this 1. So in this case, my weight is my 5 into 3. So I have 15 in the first part. All those are the weights. And that weights can actually be small weights. They're usually when I'm playing in terms of training, I said I'll put random weights, right? That random weight is usually in the range between 0.1 to 0.5 because you're learning. So the case is I've shown you a function. So that sigmoid function. When you're learning, those function will either saturate at this point or this point. So that's why you keep a small value. You can either go to 1 or go to 0. So that is how the weights learning works. I don't want to get into the maths just by words, so that wouldn't be good. But in the case of weights in that aspect, I am trying to learn something using those weights. A very easy way to say it is polynomial fitting. So if I'm telling in polynomial fitting, ax square plus ax square plus bx plus c. So I'm having a, b, c in this function, right? My goal is to learn a, b, c. Those are the weights. But a, b, c, this is a polynomial function. neural network is a very complex function. You can't actually write that function. So in this case, that's why I'm telling this W1, W2. Sometimes they even call it theta, but okay. They call this W1, W2. I am learning all these W's for this very complex function. And that way I'm learning these W, the math behind it, there's like a Newton-Gauss method, but the math behind it is just the kind of like slowly I'm learning, keep on changing until I'm getting lower and lower errors.
Thank you.
Yeah, it's like a complex function with some ax plus bx plus c like that.
Thank you, Joseph. The next question on the YouTube chat that the professors have given is, current this technology, where are they using? Which are the companies they are using? Or is there any websites regarding how they are using the technology in real-time scenario?
What technology?
Deep learning and VR.
Okay. So where are they currently using this technology?
Yeah.
Yeah. So in terms of where they're currently using, I could quickly give for this tracking and deep learning based tracking models, they're currently using it in Facebook now, became Meta. But Meta is learning vision based tracking with minimal sensors. Like I told you, this Oculus in the starting, they just wear the Oculus, but then their hands will be tracked, right? That is the Oculus, that headset will have 4 cameras in here, and that 4 cameras will be tracking the position of your hands. And the position of your hand is not like front position, back position of your hand. But with that back position, they will accurately track how your hand movements are. So that is a kind of industrial application. So it's actually been industrialized, being sold in the market for hand tracking based algorithms using virtual reality. And other methods I could say is algorithms like Microsoft Kinect. So Microsoft Kinect is using the depth camera. So you could actually walk in front of it and your full body will be shown. And you play cricket, you could play golf using Microsoft Kinect. So that in place. And Microsoft studies there's also the Microsoft HoloLens and all the studies related to that for AR. So it uses the AR camera, which is on that, to analyze the area and to do surface rendering, SLAM detection. SLAM is also another big field out there, simultaneous location and mapping. So that's another research section on VR with the VR, AR, and deep learning. And yeah, and like I said, analytical methods. So if I'm playing some game, will it give me some feedback? Would it give me some evaluation without the need of any supervisors or doctors? If I'm doing some medical procedure, how well am I doing it? That you could also do with deep learning.
Thank you. There are 2 more questions. Can we take? Is there any possibilities to VR without neural network?
VR without neural network. So in deep learning, is it?
Yeah.
So there are cases where, without the need of neural networks, there are something like speech processing. So if you're not going to use neural networks, you could even use other kind of algorithms for speech processing. But something like this, there's a research problem out there with the lip sync technology. So in a virtual environment, if I'm talking and automatically while I'm talking, that virtual avatar should move their lip correctly. It's similar to that one of the applications I shown. I give my audio and that full video is created, right? So that kind of, without neural network, you could even use other kind of algorithms for that. Other ones I could tell is this evaluation process. This whole evaluation process, I'm saying I'm doing something and I'm learning something with it. That does not need to be on a neural network. You could even use something like a KNN, because if I'm using suppose I'm doing some exam, okay? My exam is, I need to cut something correctly. That's all my exam. I'm just giving you a random thing for a medical procedure. I have to cut this particular object and I have to cut it in a nice straight line. I will do it in VR. My position and everything, I'm in a virtual environment, so whatever I'm moving, it's all known. I will cut it like this. All of that data will then be taken, and using that data with something like a KNN or even other kinds of Bayesian classifiers, I could tell how well am I doing with respect to doctors. So I will make a doctor to do this. I will record the doctor. I will get some other student to do the same thing. How good is the student compared to the doctor? I could take this data and that, and this thing does not even require any deep learning procedures. You could just use KNN classifiers, Euclidean distance classifiers, those kind of simple methods to find how good this is, how good the doctor is. There's a lot of things. These are all HCI related projects as well. So there's something known as Fitts law, which is FITTS law. It's a well-known law. It's actually a 1950 law, but it's being used in 3D AI, and even right now it's implemented in VR. So this way you'll know how good you are doing something with any kind of device. So in this case, VR devices. Yeah.
Okay, thank you. One last question. Could you brief on single shot detector?
Single shot detectors. Okay, so actually, though, when I was telling about RCN and there were other kind of detectors which first finds out the location of the object, and from the location of the object, it will then find the position of the object. Like as I was saying, suppose we're having this kind of object tracking software. There is first one full network which will find the likely location of the object. Once it finds the likely location of the object, another tracker has to be positioned in that particular location to find the location, to find the pose of the object. This is with regards to that last project I've shown you. I have two CNNs, right? One CNN, I will find the location of my hand in 2D. And then the second CNN, from this 2D, I will cut the hand. I will take this cut hand, and then I will send it to another CNN, and I'll find the actual pose of the hand, right? Those were two CNNs. That was a two-shot problem I'd done. That fusing into one full CNN is a single shot CNN, where with one single shot, you will actually find the location as well as position and the pose of the object. It can be hand, it could even be body tracking. There's even the case of single shot image detectors, which can not only track the object, but can also classify the object. So if you have seen YOLO, so if you have heard YOLO, there is You Only Look Once. There's even a V3 which is just now released, and that can not only track multiple objects, but it tracks the object. It also classifies that object as, like, if something is going, like a car is moving, it will say car and it moves along with. It'll do both of the parts. So doing both classification and detection in the same time, or in this hand tracking detection and pose estimation in the same time, these are all single shot networks.
Thank you so much, Joseph, for answering all the questions more patiently. And he's very young and he is into deep research. And there was a very clear presentation of what is VR, even for those. There are people from different departments who are listening to the talk on the YouTube. All right, thank you so much for the splendid talk and also for asking questions. Like one student had asked a question. I'm so inspired by your presentation and explanation. Can you please talk about your career journey, like how you got into IIT, the exposure you got? It will be helpful for students like us. That's the question from Maheshwari.
Career journey was, I would say it's been a good journey. I was doing my projects in BE with object tracking. I actually done a project which can track autistic children and find out how well they are progressing or how well they're improving based on some medicines. And using that project, I applied for direct PhD, and then I got into IIT Madras. And in IIT Madras, once again, I applied for placements and got into Ericsson. So from there, I finished my PhD. then got into Ericsson. So yeah, my journey was pretty good. And throughout IT, my research was on, in fact, VR. My research was on VR with biomedical engineering. That was interdisciplinary research that I was working on. Hence, I was telling all this interest on medical simulations, because most of my projects were actually on medical simulations and HCI. So with those as projects, then I applied for Ericsson and the deep learning field, and hence I'm working on NLP and even computer vision based projects in Ericsson India. So yeah, that's my overall career journey from B straight to PhD and now data science. So yeah, thank you very much, Maheshwari.
Yeah, you are truly inspirational. So that's this is what we want to get from the students. Like they're just final year students. They are going to do about their project. Like there's a large wide opening for students nowadays that you will be able to explore and you'll be able to do even more better than us. All right. And anybody from the college, can you share a thankful note to Dr. Joseph H.R. Isaac? One of you for a minute. So how was this? Like Maheshwari said, it was inspirational for her. And Ravi Ramyashri asked questions.
Yes,
Mahesh.
First of all, I wish to thank you. First of all, I wish to thank you, sir, for giving such a wonderful presentation. Starting from zero, you got like everything you covered. Starting from what is meant by machine learning, deep learning, difference between them, applications, several applications in several fields, and then what are all the challenges. Tracking. So the overall session was like very interesting, and also you showed some animational video that was very interesting. Really, we could imagine how it would be. So the overall session was very useful. Thank you. Thank you, sir.
Thank you.
Thank you, girls, and
Thank you very much.
Thank you, Joseph, once again, and thank you for all the participants, the professors from different countries that you're listening to the talk on the YouTube. And we are so inspired that you are all here in the evening time listening to the talk, and the presentation was clear and it was neat, and it was more importantly, it was understandable. Right? Thank you all. God bless. Thank you.
Thank you very much. Bye.